So first of all, what is the IUPAC? The IUPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization non-affiliated with any government. The IUPAC strives to advance chemistry in part by setting global standards for names, symbols, and units. Nearly 1,200 chemists are involved in the IUPAC project. Now, the simplest organic compounds are made up only of carbon and hydrogen atoms only. Compounds of carbon and hydrogen only are called hydrocarbons. The naming of organic compounds is referred to as organic nomenclature. There are new rules for naming organic compounds that have been systemized by the International Union of Pure and Applied Chemistry. Okay, so now that you have a brief explanation of how does the IUPAC work and what are the names for, we are ready to start.
A hydrocarbon is an organic compound consisting entirely of hydrogen and carbon atoms. They are also found in substances like natural gas, asphalt, and mineral oil. Many hydrocarbons occur in nature, that's why they are present in plants and in trees. Hydrocarbons can be divided into two groups, the saturated ones and the unsaturated ones. With the saturated ones, we have the alkanes. The alkanes, they have a single bond, and their general formula is CnH2n plus 2. In the unsaturated ones, we can find the alkenes, alkynes, and the aromatics. Firstly, with the alkenes, they have a double bond, and their general formula is CnH2n. The alkynes, they have a triple bond, and their general formula is CnH2n minus 2. And lastly, but not least, they are the aromatic, that they are the benzenes, and its general formula is C6H6.
Alkanes. Alkanes are hydrocarbons that contain one single bond. The IUPAC naming rules for alkanes can be simplified in these steps. First, identify the longest chain or parent chain. Second, number the carbon atoms, but you have to start with the ones closest to the substituent. Third, identify the substituents, or also known as alkyl groups. Fourth, name the alkyl groups alphabetically. Finally, you have to name the parent chain. And as a side note, you need to separate numbers from numbers with commas and numbers from letters with hyphens. Let's see an example. Well, first we need to identify the longest chain, that is this one, as we can see, because we have 6 carbon atoms, and then we need to give a number to the carbon atoms, but we need to start with the ones closest to the substituent. Then we need to identify the substituents and give a name to it. We need to name the parent chain. As we have 6 carbon atoms, the parent chain will be named hexane, but as we have 2 substituents that are the same, we will use the prefix D. We need to separate numbers from numbers with a comma, and numbers for letters with a hyphen. And this is the name of the alkane.
Alkenes.
Alkenes are hydrocarbons that contain a double bond, and they have the ending E.
The IUPAC rules for naming alkenes are similar to the ones used in alkanes, but with minimum changes. The differences between them are that the fact that the parent chain must have the double bond. The numbering starts from the end closest to the double bond. You must indicate location double bond of the double bond with number, and the ending is in. First, we need to find the parent chain, and the parent chain is this one because it contains the double bond and is the larger chain. And well, the second step is to find the substituents, which are these. And these substituents are methyls, so we first write the position of them. So we start numbering from here because it's closest to the double bond, and the name is 2, 2, 6 because it's 2, and 6, and then 3 methyl because we have 3 methyls, and 3 because we need to indicate the position of the double bond, so we write 3 octene, indicating that the double bond is in the number 3 counting from the end. And we also write hyphens in order to separate the alkene.
Alkynes. Alkynes are hydrocarbons that contain a triple bond, and the IUPAC rules are just the same as the alkenes, just by the difference that it has a triple bond and the ending is in "-ine". So in this example, the parent chain will be this one because it's the longest one, and we start numbering from the one closest to the triple bond, which is this one. Now we identify the alkyl groups, which is this one, is an ethyl. So the answer will be 4 ethyl, and as the triple bond is in the number 2, it will be 2 eptyne with the ending "-ine". Don't forget the hyphens.
Aromatic compounds. Well, another type of hydrocarbons are the aromatic compounds. What is special about them is that they contain a benzene ring, which looks like this. It is a chain composed of 6 carbon atoms, and it can be represented with a circle or with 3 lines. Well, for naming aromatic compounds with the IUPAC rules, they vary since we can have 1, 2, or 3 or more substituents. So when we have one substituent, for naming it is the name of the substituent plus the word benzene. Like in here we have a propyl, so it will be, but we also have aromatic compounds that have a common name. In this case, this one is known as phenol. When we have two substituents, we can either use prefixes or use numbers. So for prefixes, it means that we can have substituents in the 1 and second carbon, 1 in the second and in the third, or 1 in the first, second, third, and fourth. For the first one, it is ortho, then meta or para. And with the numbers is that we write the substituent location separated by hyphens, and we also, or commas, and we also write the parent chain, which will be the word benzene, and that will be the ending of it. So an example would be this aromatic compound that we have here. It can be either named as the ethyl is in the number 1. Here we have the propyl in the third location, so it can either be meta ethyl propyl benzene or 1 ethyl 3 propyl benzene. Remember that you need to start the numbering from the lower numbers. And in the case we have 3 substituents, we will only use numbers. Well, as a personal reflection, I believe that the IUPAC rules are important because maybe not all of the scientists or chemists speak the same language of origin, but with these rules they can speak the same language regarding chemistry.
I think that the IUPAC rules are important because it helps you to see the compounds in a graphical way instead of just words, so it helps you understand it.
I learned that these compounds only contain hydrogen and carbon, and that the IUPAC rules only apply for hydrocarbons, and that they have different bonds.
My personal reflection is that with this video, we can help other people or students learn about how to name hydrocarbons and how to classify them.
Organic chemistry is very important in our lives because we use a lot of materials that with organic chemistry, and we don't really know the structure of them.
So with this project, I learned that organic chemistry is present in our daily life in almost everything. I also learned how to classify alkynes, alkenes, and alkanes in a really efficient way.